Hello, everyone. Today, we are continuing with tuples in TypeScript. So what's tuple? A tuple is a fixed-length array where the types and order of elements are strictly defined. Unlike regular arrays, tuples allow you to specify exactly what type each element should be and how many elements the array must contain. They are commonly used when working with a known, limited set of values. Let's first understand how it's different from a regular array. We'll start by defining an array called person_r. Inside this array, we add Alice and 25. Now let's define its type. If we say it's just an array of string, we get an error because 25 is a number. So we define it like this: string number, meaning the array can contain both strings and numbers. One thing to note is that regular arrays allow us to add elements to the beginning or end without throwing any errors. Now let's see how tuples are defined. We'll define another variable called person and assign the same values as before: Alice and 25. But this time, we'll define it as a tuple by explicitly stating the types and order of the elements: string, number. This way, we're telling TypeScript that this tuple must have exactly two elements: the first a string and the second a number. Now, if we try to add a value to the beginning of this tuple, we get an error. That's because we didn't define a third value or type for the start or the end. The same thing happens if we try to push a new element to the end. It throws an error since the tuple expects only two values. Let's now remove the extra element and print the tuple to the console. Before that, we need to compile the code as you know. We can use the npx_tsc command for that. Once compiled, we can see the result in the console. Now here's a question. Can we add new elements to a tuple using methods like push? Let's try using the push method to add Wonderland to our tuple. Interestingly, no error is thrown. Let's compile the code again and check the result in the console. And yes, we can see that Wonderland was added. This shows us that while tuples are supposed to have a fixed structure, methods like push, pop, shift, unshift, and splice still work. But what if we try to directly change one of the elements using its index? Will that be allowed? Let's see. We're updating the number value at index 1 with a new number, and as you can see, it doesn't throw any errors. Now let's log it to the console. Let's compile the code again and check the result in the console. As you can see, we successfully changed the value without any issues. However, if we try to replace the number at index 1 with a string, we get an error, because we define that element to be a number. So in general, if we try to assign a value in a different type to an element at a specific index, TypeScript will throw an error. Here, assigning a string to a number results in a type error. However, if we replace it with another number, it works just fine. So yes, TypeScript will enforce type safety within tuples. Now, we're defining a tuple where the first element is a string and the second is a number. Then we use the push method to add a new string value to it. As we've seen before, TypeScript doesn't throw an error in such cases. Now, what if we want to completely prevent any modifications to the tuple? Just like with arrays, we can use the read_only keyword. Immediately, we see that the line with the push method now throws an error, which is exactly what we want. Previously, we were already getting an error when we tried to modify the tuple directly. But now we're enforcing immutability explicitly. Here's something else to notice. Even when TypeScript shows errors in our code, the code might still compile and run, unless we tell the compiler otherwise. Let's demonstrate that. With an error in place, we run npxtsc again. Although TypeScript highlights the error, the code still runs and London appears in the output. That's because by default, TypeScript still emits JavaScript even if there are type errors. TypeScript performs type checking only at compile time. Since the code that actually runs is JavaScript, the read-only property isn't enforced at runtime. In other words, TypeScript will warn us about the issue, but if we go ahead and compile the code anyway, JavaScript will still execute it, even if it violates the read-only constraint. So how can we prevent that? We go to the tsconfig.json file and enable the no emit on error option. Now when we compile, TypeScript stops the process if there are errors, and it won't produce a JavaScript file. Let's test that now. We'll bring back the previous error, comment out the already compiled JavaScript line, and then compile. As you can see, this time London does not appear. Now uncomment the line again, compile once more, and confirm the result. The JavaScript wasn't updated. In the TypeScript file, we can see that the line with the error, line 89, is still commented out in the JavaScript output and hasn't been transpiled. This means that no JavaScript is emitted, so we get a safer and stricter development experience. This is a good reminder. Enabling no emit on error is not just about tuples. It's a general best practice that we ideally should have set up from the beginning. Let's now comment that part out and include the error message in the code as a reference. All right, moving on to a new topic, tuple destructuring. We'll define a tuple called numbers with two elements, both of type number. Let's assign two numeric values to it. Then, using destructuring, we extract these values into variables x and y. Finally, we log them to the console to verify. Let's compile the code again and check the result in the console. So as you can see, tuples can also be used like regular arrays in scenarios like this. Here's a summary of what we coded today. Tuples provide better structure, type safety, and readability in scenarios where data has a predictable format. So today, we covered tuples, how they differ from arrays, how to define and restrict them, and even how to enforce stricter compilation rules using TypeScript's config. That's it for today's lesson. We will continue exploring objects in the next video. Thanks for watching, and have a nice day.